All right, welcome back to a new TouchDesigner tutorial. And in this one, we are gonna look at blob tracking with pops, also called plop tracking. We're back with the bad jokes, yo. Yeah, so this is a more of an artistic way of doing blob tracking, but as you can see, it works very nicely and it's very fast and very flexible. So you can use different inputs, any scale, any aspect ratio. We can determine how many particles, basically how many points we see. We can also have just one blob or two. So it's yeah, it's really quite flexible. We have a threshold and it's fairly fast. The heaviest thing is actually the text, I think, because yeah, with pops pops are just fast as hell. Anyways, without further ado, let's rebuild this whole shit together and start from scratch. Right, so we're gonna start with an input and I will just copy that. So I'm using a movie file in, and I'm also gonna copy the other thing. I could have also just not delete them, but whatever. So I got these two videos. We can also use a video device in, so camera. And I will bypass that for now. But yeah, one thing I would advise you to use here is videos with a static camera and a moving object. So not actually a moving camera, because if everything is moving, then the effect doesn't look so cool. So yeah, jellyfish work perfectly. Also dancers, whatever. You're free to use your creativity. I mean, this effect is has been around for a while, but I wanted to get the pop approach. Let's use a fit here. And for that, I'm gonna use the parent panel size. So let's move out a bit and look at our plop container. Now here, you're gonna have a different resolution. Choose whatever resolution you wanna be working with. So this could be square, this could be 1920 by 1080 or 1280 by whatever, 720. This is gonna be important. So make sure that you have the right resolution set up here. It should usually be the same as this one, unless you wanna crop it. Right. So then I'm gonna add a null, which I'm gonna call input. So this is the main starting point that we're referencing. I'm gonna quickly show you the old approach before we start with the proper one, so you don't have to follow this. I'm gonna add difference here and a cache, right? And then we can put that in here and we can output maybe one frame before. So you're probably familiar with this. This basically gives us an output of wherever things change, right? So it's basically the difference between the current frame and one frame before, or X amount of frames before. So now my idea was to convert this right into pops, right? You can polygonize this. Maybe go down with the resolution, change this to density, threshold 0.1, and then you get this. And then you could use that as a base for cloning rectangles, for copying rectangles. And you can manipulate these points, you can delete them, you can use a particle on them, as we're gonna do. But I found that this approach does not work as well. So instead of directly converting from and doing the differentiation operation inside of tops, we're going to use a bit of a different approach. So in that case, I'm going to use a point generator, and you may follow now again. And I'm going to use a rectangle. And now it already becomes important that we use the parent thing. We could also just reference the input, but I think it's a cleaner way. So I'm going to do parent parentheses dot width divided by parent dot height. So that gives us the aspect ratio, which is, or 16 by 9. That's always, I mean, it's not the aspect ratio, but it's like the, I don't know what it's called, that number. It's a number that we can work with. And it's always 1.77 or 1.78, I guess, with 16 by 9. Then we want to use the texture map. And we don't actually need to do anything, but we're outputting text, which is important. And then we want to use lookup texture, as we have done a few times now in previous tutorials. I'm going to use this as an input. We're going to use text 0 and text 1, and we are going to output color. Now we have the colors of, like basically we changed our texture into points, and we can go to more points, maybe 100,000. So we have a lot of points to choose from. So now the cool thing is we can do the operation that we did here now on pops, which gives us an attribute output, which is much better to work with than just random points that were converted. So we're literally doing the same thing, just with a math combine, but we're also going to use a cache. And I'm going to actually go and output -2, so 2 frames back, and then input that into here, because it just gives us a bit more of a difference. So difference is really just a minus b, so we're going to do a minus b, but we don't actually have the attribute of the second one. So we're going to go to inputs here and select color. So this is basically going from the second input, and I'm going to call this color cache, because we already get a color attribute from the first input. So we want to differentiate between them. So we have color and color cache. So now we can do color minus color cache, and that you can already see right now that does the same thing as kind of what happened before here. But actually it shows that here because the result scope is color, so it automatically converts it. But I actually want the result to be called difference. So we're creating a new attribute called difference, which is the result of color minus color cache. So the current color minus the color 2 frames ago. Right, so we can add a pop to that, and that's gonna slow down your whole project quite a lot, because it's actually converting 100,000 points right now into a DAT. So also on the CPU. So usually this is not something that you would do or live, or you shouldn't have this like be turned on all the time. But even if you just turn off the viewer, your FPS goes back to normal. But like just the display is very intense. But it's very useful to have a look in here. So we can see we have 4 different differences. So if it's a float 4, which we can also see here because it's an RGBA, the color, right? And we converted color to the difference attribute. So it's also a float 4. So we have 3 different, because like the 4th one is we're only looking in 3 dimensions or 3 colors. We're not changing the alpha, so the difference 3, the 4th difference is stays the same. Anyways, so here we have some values to work with. The differences between the last frame and the 2 frames ago and the current one. But you could see also that some of these are minus, and actually I just want the absolute value. So I'm going to do this, abs a, and then difference. So this is just going to output the difference only in positives. So only plus. So now I'm going to add another math combine. And I just want to have one value to work with, a threshold value. So I'm going to do a plus b plus c. I'm going to use difference and then .r. Just copy and paste that. .g and .b. And the result is threshold. There we go. So if we use this instead, we can now see we got a threshold value here that we can work with. Most of these are very low because we're actually working with, again, 100,000 different points, and only a few of these are going to be relevant. So you're going to see what I mean now. When we add a delete, we can go to attribute and delete by attribute by selecting threshold. And now if I go up with this value, only the points that are above this number are going to be kept. Everything else is going to be deleted. So that means that we only have like somewhere between 0 and maybe, I don't know, 400 points, something like that. I'm just going to do 0.7 here for now, but this is I'm going to actually mark this red because this is a majorly important value or parameter to work with, that to change later on and to play around with. So basically we have a very similar outcome to what we had here, right? Like being the difference just in points. The cool thing is, mainly what's important is that we have the difference as an attribute. So the strength of the difference, basically. All right, so before we actually go on, I want to set up the render. So I'm going to add a geometry as well as a camera. And for the camera, it's important that we use the parent. So I'm just going to copy this parameter from the point generator and paste the expressions here. So it's just parent width divided by parent height. And as it's orthographic, it's going to be perfectly aligned with this thing, this object with the points. So I'm going to add a render, and again I want this to be the same size as my parent. So I'm just going to do parent dot width and copy paste, because I'm lazy, parent dot height. Okay, might want this to be 32-bit float. Doesn't have to be, but it's nice. Let's turn off these viewers. Let's add a null, call it BG, and show that in the background. I'm also going to add a transform and go up 1 here and comp over background color. Now, actually, you can kind of see that. I'm not sure if you can see it well, but we can see those points there. But actually, I want to use a line mat, which is going to result in there not being anything. But now I'm going to use a copy and some rectangles to make that visible. So let's add a rectangle. I'm going to change its scale to 0.05. Connectivity quadrilateral. That's correct. I'm absolutely professional. I'm going to add a copy here and put that in here. And then put that in here. Let's turn off the viewers. On my line, I want no width far, like width far 1 actually, width near 0.8. And on my line, I'm going to turn off the far color and just make this white. Let's turn on blending and go down with the near alpha to like 0.7. One more thing before we keep going there is that I'm going to use a select top and use my input and then do comp over and then put that into the second input. So now you can already see, and this was actually not that easy to get the hang of and to do it correctly, but now it just works perfectly, that everything is aligned. You can see it. It's perfectly aligned to the jellyfish. Same thing here. We do use a different video. So yeah, that is working nicely. But the thing is, so first off, right now we're not actually much in control of how many points how many rectangles we're showing. So first, let me actually go ahead and turn all of these viewers off. So the thing is, we get a very random number of points and we're not in control of how many. So one idea would be to use another delete. Go to thin, turn that on, and then you can just go up with the thin random. So now it's gonna like just be less. It's still kind of random. It's somewhere between 0 and maybe 5 points, but they're still very flickery and random, and yeah, we're not much in control still. So my preferable way here is to use a particle pop actually. So first off, this is going to look a bit weird. It's like it's kind of just drawing particles, which yeah, might be interesting for you. That's not what I want. So first off, I'm going to change the life expectancy to frames and then go down to like 7. And then let's do a reinitialize and start. And that already gives us a lot more, like it looks a lot smoother. Then I'm going to change the maximum particles to like 24 and the birth rate to 1000. So now it looks very stuttery. So basically what we got to do is change our life variance to 1. So basically 100%. So that means that like if life variance is down to 0, all of them are going to get turn 7 and then die. If we change life variance to 1, the way I understand it, it's now like 7 is the maximum and 0 is, or 1 or whatever, is the minimum. So it's a whole range. So it doesn't look like they're all being like spawned at the same time. You could also go up to maybe 500 here, or it could also just be 1. So you're way more in control of how these particles are behaving, which is a very good thing, I think. Just to explain the connectivity, so first I'm going to make this red. The connection now to the delete is that if we go down here, basically, and maybe let's do 240, the more we go down with the threshold, the more these points are going to be distributed, or the more positions there are to choose from for the particles. So the particles are going to be, they have more points to be born at. So the higher we go, the more close to each other they're gonna get. And like if we go very high, they're gonna be all kind of stuck on the same points. So I think it's about finding a balance, like always in life, of like how many particles and how much of a threshold you want to have. Now the thing is, they're all the same size, so I want them to scale based on the amount of difference. So we want to use the attributes that we get in here, so mainly difference actually, or just difference. We want to use that afterwards. So to parse that through, to push that through the particles, you can use the attributes, input attributes, and just do difference. And now we can use that afterwards. All right, so I'm gonna add a math combine, and I'm gonna do just A, and I'm gonna use difference, and we want to turn difference into scale. But the thing is, scale for the copy pop has to be either a float 1 or float 3. So we cannot use difference because it's a float 4. So we have to use just RGB, which is only what we're interested in anyways. And then let's call that scale. So now we're converting one to the other. Now on my copy, I can go to template, turn on scale, and use scale. So now you can see they're all much smaller. So one idea would be to range them. So we can use a rearrange and select scale. And then we could do maybe just map high, maybe just to like 3 or something, right? Or 2. Oops. And that already works pretty much. But I want this to be more accurate. So one way to do that is, it might seem a bit like too much work for the result that it is, but it's nice to know about this anyways. So add an analyze, there we can output the minimum and maximum, and they're going to be output. We actually also want to use the difference instead of the P. So using our difference, and yeah, we're outputting that by using a pop2 dat. And now we can use that as a minimum maximum, because I selected minimum maximum here. We have a lot of different things to choose from here, which is very useful actually to analyze our points. So now what I can do is I'm just going to call this min max. And then I'm going to change this to 3. And map from low, I'm going to put in OP, min max. And then we want to choose row 1. And for the minimum, that's in column 5. So 1 and 5. And then same here, but 1 and 6, because the second min is in 6. And then we can do the same thing again for high, and then do 1 and 1, and 1 and 2, because X and Y min and max are in 1 and 2 column. And then now we can do 0 and 1. Maybe we don't want to use 0 and 1, but 0.05. And maybe even a bit higher, like 1.2. So now it's a bit more accurate, and it looks a bit more interesting. Again, not necessarily something you have to do, but I think it's an interesting way to see, and it's going to be sort of very accurate as it gets for now, for the setup that we have. Now another thing that is actually super simple with pops is that we want to connect these points with lines, right? So you might have already guessed it. We can use the proximity for that. From there on, I want to use a merge. Let's put that in here, put that in here, and that's it. So easy to do. I love the proximity pop. So nice that we've got that now. I'm going to change you can just mess around with the distance. So you can go all the way up to 1. So all points are going to be like wherever they are, basically, they're going to be connected. I'm going to go to my beloved 0.24, maybe a minimum of 0.05. And then maybe max lines per points could be 2. So you can see the more you have, the more of a kind of a net it's going to be. And the less you have, the more it's kind of going to be individual lines. I think this looks pretty cool. All right, so let's look at the text, and then we're going to look at some post-processing, and then we're good. We want to use whatever comes out here. So I'm actually going to add a null, because let's just call this pop data something. So this is where we're like going into copying and proximity, and everything that happens before is a different story. But from here on, what we can do is we can right click and do a pop to again. So in the pop to, I can select just P, because I'm only interested in the position data actually. Then I'm going to right click and select, because actually I only want P0 and P1, and I don't want the header. So first off, I'm going to cut off the header, and then I'm going to do index 1 to 2. So I only got those. So that's the text that we want to use. But the thing is that right now it's in the range between minus 0.5 and 0.5. So now we want to use something like a remap function. So it actually remaps onto our correct pixel size. So to do that, I've added an evaluate, and then we want to add a table. Set the size to 1 by 2. And now I'm just going to copy these. These expressions are also in the video description. So just copy them there. And so this is the first one, and then the second one. So these just basically make sure that we use the aspect ratio and like just map, like using the parent height and width again. We're going to remap these. So if you look now, these are actually mapped to be the correct position on the canvas. Now what we want to do is we want to use these, like these are the actual XY coordinates for the text. And now we want to use the XY coordinates next to each other, separated by a comma, for the text, like to be displayed as a text. So we can do that. I stole all of this from other tutorials. So I'm going to use a convert and do to text and just do comma space, and then use a second convert to table, and doesn't have to be anything in there. So now we want to merge these. So I'm going to add a merge from here, merge them, append columns, and then we want to use another table, which is going to be 1 by 3, and we're going to call it X, Y, and text. Then we are going to merge this and add a null, and I'm going to call this text spec. And then from here I want to add a text. I want to use I don't know why it looks so terrible. I want to use Arial. I just want this to be 9.9. I'm going to use this as a specification DAT. And then now if we use a comp here, just do over, we can put that in there. And then you can see the text is displaying X and Y with two, what's it called? The 2 digits after the comma, after the point. I don't know what it's called. I'm not a native speaker, also not a mathematician. So that is something that we can use. Another idea would be we can use a select that here, use the pop, and then we could just select again without the header, and then just do 0 here. So we just get the index, and then we use that instead of that. So instead of the coordinates, we just use the text here. Maybe we go up with the font size. So now you can see we get like the individual indices, just the numbers basically. Yeah. Another thing I'm going to show you, some post-processing stuff, is that we can use a blur very simply, because right now it looks very much like just like an overlay, and without like, because it's so sharp and it doesn't look very integrated. So I like to do subtle things here to integrate it. So filter size 2 and sample step maybe 1.5 on the Y, and I feel like it immediately looks a bit more integrated. And another thing that's nice to do, as I really like to do often now, is using the bloom. So on my bloom, I want to use pre-black level of 0.1 and bloom fill of 0.6, and then no bloom min radius, basically just set it to 0. So if you do an A/B, I think the second one looks much more interesting. You can also go down with this, makes it even more blurry. or you could also go down much more of the, or a bit more with the intensity, something like that. I think is nice. On our line, we could also go down further with the opacity. On our text, we might actually go to color and set that maybe to like 0.7 as well. So it's a bit more subtle. Another thing is, and that's why we use the quadrilaterals, is that we can now use a constant material here instead of the line. So that's going to give us blocks, which already on its own looks pretty cool. But now what we could also do is from our select, we could use a level. Let's just put that here. And then let's use that here, composite with this. On our level, let's do inversion. Composite multiply is fine. And then maybe just skip those. And then basically the boxes use the inverted part of this image. And then we're compositing that. Also looks pretty cool, I would say. So it's a very simple trick to make this look fancy. And one last thing I want to show you is that we can also add quantization. So we can quantize it before the null here. Quantize round. And then maybe do like 0.1. So basically, like the points are going to appear on a grid. So let me do line material again. So line and the inversion method here also looks pretty cool. So now you can see, yeah, if I change it down, it's like the grid is obviously going to be smaller or larger. So obviously all these points are going to be pretty much like the rectangles are going to be the same positions. But I think it looks really cool as well. So let me show you with the camera. Yo, it's me. It's actually very bright right now because surprisingly the sun is shining in Berlin. How amazing. But yeah, this works pretty well. Actually, my camera is flipped. That's why I'm confused. But yeah, we can use any input. And again, it works best if it's a static camera and a moving object. Yeah, I think that's it. Play around with this. If you have any input, I'm happy to hear. I'm still learning pops, and these are just things I come up with. As I said, like I can maybe quickly show you what the idea here was, but basically we have points here as well. So I could just copy this particle and then use this for the copy. So right now, of course, there's no scale, but it sort of works the same way. And yeah, you can totally go that route. You can use a delete with fin as we did before. You can even use a neighbor to determine the scale. So if there's more neighbors, then higher scale. So these kind of things, but it doesn't work as well as this, I would say. So I prefer this method, but I just wanted to show you that is totally possible. If you have another idea, please let me know. And yeah, thank you so much for watching. I will see you on the next video. And yeah, thank you so much for everybody who is supporting me on Patreon as well. I deeply appreciate it. Yeah, just wanted to say that as well. See you on the next one.